going to use that the cross product method of calculating area of a triangle just to kind of make things a little bit easier for ourselves. But here we have this e to the x function, y equals x e to the x. Okay, that's that curve part. And then we have this linear function, y minus e to the x equals 0. And we're going to find the biggest triangle that we can make using this shape. Okay, so let's zoom in a little bit here. So the triangle that we're going to make is going to be somewhere along this curve, okay, and those two intersection points. Okay, so there's my triangle that we're trying to maximize. That coordinate is 0, 0. Okay, this coordinate here, where these two intersect, I think it's going to be x equals 1. And y equals e, it looks like. So this is going to be 1 and e is my intersection point of those two graphs. And then this coordinate here that we're going to use is some point along the line. Okay, and so that's going to be our k point. Okay, so it's going to be k, comma, k e to the k, since we're using the coordinate along that curve, y equals x e to the x. Okay, so there's the setup of my problem. We have to make sure we be able to set it up. Now, with optimization problems, we need to come up with an equation for the area. Okay, so in this case, we're maximizing area, so I need to come up with an equation for the area. So what I'm going to do is I'm going to use that matrix method or the cross product method to come up with an area equation. So the way it works is this: we're going to list all our coordinates, okay, 1, e, and we'll do it in clockwise order, k e to the k, okay, and then 0, 0, and then we're going to repeat that coordinate here, and we're going to do the right hand cross product times the subtracted from the left hand cross product. So I'm just going to start with this one here. So I get k e, this is 0, this is 0. Okay, so it's k e, and then we're going to subtract the other cross product. So this is 0, this is 0, and then we get k e to the k. Okay, oops, sorry. So this diagonal cross product is plus e, that's right, k e to the k. Okay, so we're going to subtract all that from that first one. Okay, and then divide by 2. So the area of the triangle is going to look like this. Okay, this represents the area of my triangle. Okay, so simplifying this, we end up with the area formula is going to be A is equal to 1/2 times E times K minus K e to the power K. Okay, and we want to find this as a function of K, so this is my area as a function of K. So I'll write like this: area of my triangle as a function of the value of K. So it's going to allow me to find the best K to maximize this area. I want the biggest area here. Okay, so I'm going to differentiate this. So I'm going to find my A prime in terms of K. So I want to differentiate with respect to K. So this is going to equal my linear function. So that's the slope. This is going to be a product rule. Okay, so it's going to be, sorry, this is not it's a product rule because K is our variable. So we're going to end up with 1 times e to the k plus k times the derivative of e to the k is itself. Okay, so there's my product rule, and there's my derivative. So then I'm going to solve this equation. It's going to be 1/2. Switch that to e. So this ends up being e to the k. So e minus, and I'm going to factor out e to the k. E to the k 1 plus k. Okay, so I have to solve this equation. This equation I'm going to need a calculator to solve because it's not a simple, straightforward